Hello everyone. So today we're going to be looking at our fourth lesson on NFTs. Third lesson was on NFTs. This fourth lesson is going to be on fungible tokens. So yeah, similarly, I'll just do like an introduction and the contents of this lesson. Hello Oscar, mate. Haven't missed anything yet. Just got started. You missed our discussion on FTX, but we can talk about that a bit more a bit later, and I'm sure you'll be able to give some good insight on the whole situation.
That was an insane situation.
Crazy, isn't it?
all round. Sorry I'm late, man.
No worries at all, bro. No. Yeah, no, there'll be a point when we can talk about that a bit more later on. But yeah, so we'll be doing fungible tokens today. Their utility, what can they be used for? How are they different to non-fungible tokens? Again, I'll show you some resources where you can look for help. Then we'll go to create and mint a fungible token. Very, very similar to what we covered last week, which is minting non-fungible tokens, like almost identical, except there's one key difference. Again, we'll look at that later on. Then we'll transfer it, so we need to associate it to the account, send it to that account, and then after that, sneak peek into next week. Next week we'll be covering atomic transactions and building complex transactions, rather than just sending one thing to someone else, actually building a transaction which is exchanging 2 or 3 or 4 different. So, what is a fungible token? Unlike non-fungible tokens, fungible tokens are actually identical to each other. So every fungible token is of the same class, of course, of the same token ID. Every fungible token is exactly the same as each one. And what I mean by that is an example of a fungible token is something like HBAR or Bitcoin. Because if I have 1 Bitcoin in my wallet and all of you guys have 1 Bitcoin in your wallet, I wish we did, then all of these Bitcoins are totally identical. No Bitcoin has any higher intrinsic value or anything or better properties than all of the other Bitcoins. So that's what I mean by a fungible token is identical. Secondly, is that it's divisible. Of course, with non-fungible tokens, they're indivisible. So you can't own half of an NFT. However, you can own 0.5 of an HBAR. Can own 0.5 of the token which we'll be making today. Now, something that you can do with Hedera Hashgraph is you can specify how divisible said token is. So, for example, I can say that a divisible token is only divisible factors of a tenth. So it can be 1, 1.1, 1.2, 1.3, 1.4, etc. But equally, you can then make it even more divisible, and you can say you can go in fractions of millionth, for example. Then finally, they're equal, similarly to what I touched upon, the identical part. A single unit of any given fungible token is worth the exact same as any other one. So what can they be used for? Let's have a bit of a discussion here. Obviously, last time we spoke about how non-fungible tokens can be used for tokenizing things. And I think similarly, tokenizing kind of off-chain assets and putting them on-chain. Similarly, there's definitely a use case for this regarding fungible tokens. But I'd like to open it to the floor if anyone has any suggestions what fungible tokens in particular can be used for, why they may be better at tokenizing certain things than non-fungible tokens, and also why they may not be so good. Yeah, I'd like to hear some of your insights.
You can tokenize energy, like different forms of energy, oil, gold, or coal, gas, electricity, that kind of thing.
Actually, and I've heard, who was I speaking to? I think, of course, yeah. So there was a test recently in the US. I was speaking to he used to be. I had the opportunity of having a lunch with the old CEO of the National Grid, who's currently doing a lot of other stuff at the moment. He's retired from that, but chairman of other things. And basically, he was talking. I asked him about blockchain and the application of blockchain in the context of smart grids. And actually, there was a test carried out in, I think, North Carolina in the US, where people were producing their own energy and actually sharing it around using distributed ledger technology. So exactly like that, I guess if you're able to tokenize the energy, because really you can really tokenize anything, but if you can then tokenize the energy, you use the hash graph or blockchain or whatever distributed ledger technology that you want in order to transfer who's the owner, sell it, for example, exchange it for something, perhaps give it, maybe you could even stake energy. I don't know. What is on the staking point? What does anyone think about staking and staking fungible?
It's a way of investing, sort of. So you put in a certain amount of money, and if you hold it for a certain amount of time, then you get returns on that, which might be potentially higher than what the current bank gives you, or I guess it depends on the protocol that you're using.
You just got to hope that the dollar value also, the fiat value also increases as well.
Yeah.
Because I guess if you stake something for 100%, then it decreases in 50% price than anything else.
But in Hedera, Jake, doesn't it give the node that you stake to more weight in the consensus?
Well, actually, exactly. So yeah, staking, when it comes to actually providing, because obviously you may hear lots of blockchains, their method of consensus isn't proof of work, which is the traditional Bitcoin and original Ethereum way of validating and keep ensuring that the blockchain is accurate. A lot of people actually now use proof of stake as opposed to proof of work because it's less energy intensive and more scalable. This is the same mechanism which Hedera Hashgraph used. So yeah, that's used basically, each of your HBAR tokens are staked to a node, and that then corresponds to the voting power that the node has in order to keep the transactor to say this is kind of the correct version of the ledger. And just on that, with kind of voting, I know Max, you can't talk unfortunately, Mike's, because your mic's a bit dodgy, but certainly voting is something I think where fungible tokens can be used. Perhaps linking that in with the weight that let's say you have 10 tokens, maybe your vote is 10 times as much. How you get that token, that's obviously another question. Whether that's even fair is a different thing, but perhaps even with, I'm not sure, has anyone yet? It would be great. Okay, yeah. So Max had just said, yeah, I think.
Another thing that I didn't mention, but at Get Protocol, so we do ticketing. So
Yeah.
we're doing a staking program where transaction fees are distributed equally among the stakers. So they're given like X get, which holds the value of get plus the transaction fees. So it kind of increases over time.
Right. Okay. Yeah. And actually, that's a perfect example. Just to touch on what Max said. Yeah, he said there's great functionality for government in the future using fungible tokens.
There's a idea called the network state by this person called Balaji Srinivasan, and it's kind of the idea of a nation state using cryptocurrency to hold their value, and they're using like governance tokens as well. It's really interesting. There's a podcast that I listened to recently. If anyone's interested, nation
Max
state.
is typing. Maybe he's heard of it.
Yeah, it's really cool.
Basically,
cool idea.
I was thinking, yeah, cool. Yeah, Oscar, regarding the XGET, I think that's also a perfect example where you then, so I guess initially you exchange it for a 1-to-1 ratio, then over time the XGET appreciates relative to the GET token, yeah?
Yeah, exactly.
Okay. So actually, we've touched on this in one of the last lessons, but Stader and Stader Labs with their staking of HBAR, that's actually they do a very similar thing. How it increases in value, I'm not too sure. I'll have to go over that, but it makes perfect sense regarding your the way your network's running, Oscar, where the transaction fees get added into the pool, and that's what makes it increase in value. So that's really cool. Again, this is all like made possible because you've got fungible tokens which can be accounted for, verified, totally transparent. People can people can look at it and go, okay, this is right, this is wrong. Unlike, for example, with FTX, where I heard that there was some back end, there was some custom SBF made some custom like loophole in the back end where he could send funds away from FTX without triggering any sort of alert to authorities, employees, for example, which is crazy. Lots of juicy conspiracy theories there. Right, I'm going to move on. So yeah, resources you can check out again, the documentation. I'm not even going to show it, to be fair. Sorry for the background noise. But yeah, documentation on Hedera Hashgraph. They've got a nice tutorial on how to create your first fungible token. But now let's get kind of to the actual coding part. So we'll do, guys, for those who've been here for the past 3 weeks, you hopefully know this like the back of your hand. You set up the client. So the client is obviously the account which pays for the very, very small transaction fees on the Hedera Hashgraph. Then we'll be creating our fungible token. So similarly to how we did with the NFT, you create the token. Then after that, after you've created the token, you then mint it. Now, one difference between fungible tokens and non-fungible tokens on the Hedera Hashgraph is that when you mint a non-fungible token, then you can only mint one at a time. However, when you mint fungible tokens, you can actually mint thousands, hundreds of thousands, however many you want. So that's one kind of key difference. Obviously, you can create a loop in your code which just mints non-fungible tokens. So that will make it a bit easier. But regarding fungible tokens, you can mint hundreds of thousands at a time. Then we'll transfer the fungible token. If you've got a Hashpack wallet, which I think most people here do, then you'll be able to transfer the fungible token onto your Hashpack wallet. Then we can actually check it on our wallet and also check it on Hashscan. One thing that I didn't mention on here, I did on the first slide, is we need to associate our wallet with the token. Now, again, Hedera Hashgraph offers this functionality where you must associate yourself to a particular token, just so that it prevents you from getting just junk tokens in your wallet. I think it's a good feature. Adds an extra step, which perhaps might be seen as a bit tedious, but I think regarding things like Ethereum, which traditionally have been very expensive, it's quite unplausible that people will just suddenly send fake tokens or junk tokens to your wallet. But because Hedera Hashgraph is so cheap, it actually becomes a possibility. So yeah, you need to associate yourself with a token first. But like I said, let's get on the code. So if everybody opens up their folder, their directory, their folder, which they're working with, mine's over here. And what we're going to be doing is we're basically going to be modeling it off the off this send NFT and create NFT. We're basically just going to be modeling it off here. So like we do with the send NFT, we're also going to be doing a token create transaction, because at the end of the day, they're both tokens and we're creating the transaction. The only difference is that we're going to be able to specify how many we initially want, and we don't need to include this set token type. But let's get started with it. So we'll just create a new file. So this one would be send ft. I apologize now. So this working directory is going to be very, very filled up now. Usually when you're writing code, you want to create it in folders, make it so that it's a bit easier and a bit more manageable for us simplistic humans to be able to visually process. Been good. Okay, so nonetheless, right. So we've got our create NFT file, which we're just going to be modeling things off. So to be honest, all I'm going to do actually, I'm just going to no, I'm not. Okay, I'm just going to copy this top half of it. We configure our client. So we're saying, okay, yeah, client for testnet, set the operator with the account ID and with the private key. And so I'm just going to copy all of this stuff. Copy that. Let me zoom. And over in this new sendft.js file, then I'm just going to paste that in. So do that with Control V, right click and press paste. And now we're going to create our new function. So we're just going to say, okay, we're going to make a new async function, and it's going to be called send NFT. Not going to take in any arguments. And inside our function, we're just going to follow the same flow that we've been doing for the last 4 weeks. We're going to be making our transaction. Our transaction equals a new token create transaction.
Sorry,
And
Jake, is the async function, should that be send FT?
it should be, for sure.
Oh,
yes, yes, yeah. Now, right, so again, it doesn't, like, if I was to run this file as send NFT, and over here, as long as I called the same function, it doesn't matter what it's called, it just matters what's inside. But you're right, it should, from a logical perspective, it should be called the same thing which we're doing. So we're sending, and it shouldn't even be called that. We're going to be creating a fungible token. So this first file, yeah, I apologize for that. It's not going to be the send FT. It's going to be create FT, create fungible token. Again, it doesn't actually matter what the file name is, but just for a logical perspective, you should call it what it's doing. And what this function is doing is it's creating a fungible token. So yeah, this is going to be called create FT. Apologize for that. And it's going to be a new token create transaction. And I'm just going to reference the documentation again, because it's always good to look. Hedera. Find it over here in the SDK section. SDK stands for Software Developer Kit. Our transaction, our token service, create a token. And all of the different stuff that we can have is over here. These are all of the different methods that we can apply. And in the previous lesson, when we were creating an NFT, didn't set too much stuff. We only set a token name, we set a token symbol, set the token type. Now, the create fungible token, it's not necessary to set a token type. Now, that's because if you choose to exclude this, it will automatically assume that you're doing a fungible token. However, if you specify non-fungible, that's when it will decide to do a non-fungible. We also set a treasury account, and we set the supply key as well. If you can remember, the supply key is the key which is needed to mint or burn transactions, mint or burn NFTs or fungible tokens. Now, if you choose not to include this supply key, it means that you'll be unable to mint a new token. So if you want to kind of mint things in the future, then you will need to set a supply key. It doesn't matter whose supply key it is. It can be mine or someone else's, as long as when you then go to mint it, you sign with the same supply key which you've set, then it will be fine. But as you can see in the documentation, there's all of these other different properties. So, for example, we can set the decimals. Now, this particular one is only relevant with fungible tokens, because obviously, like I said, non-fungible tokens can't have decimals. You can't have 0.5 of a non-fungible token. However, you can have 0.5 of a fungible token, presuming you set the decimals. You can set the initial supply again. We'll be setting the initial supply. You set an admin key. What the admin key does is it allows you to basically edit any of these keys. Now, if you do not set an admin key, then you will not be able to change the token once it's been created. This KYC key is obviously know your customer. Now, what this does, this is quite a cool, powerful feature. The KYC key actually basically says, okay, nobody can have this token unless I specifically allow them to. So the person who has the KYC key, they're allowed to grant KYC access to a particular account ID, and only then will they then be able to receive the key. They can also choose to revoke KYC access. Then you've got the freeze key. This is pretty similar to the KYC key, except with one difference, is that by default with the KYC key, nobody can have it. You have to be granted KYC first. However, on the flip side, with the freeze key, everybody is allowed to use it until you specifically freeze them. So that's kind of the main difference between the two. Wipe key, this one is brutal. This one basically allows the key holder to wipe any amount of token from any person's account. So again, if for example if you're buying a token which has a wipe key, it should be like, okay, why does it have a wipe key? If it doesn't include a wipe key, like our create NFT doesn't include, and similarly we're not going to be adding a wipe key to this fungible token, the power to wipe someone's account is nullified. You're not able to do it. So you have to build a token with this method in order to be able to actually use the functionality. Supply key we've already covered. So the supply key is the key which allows you to mint or burn a transaction, burn a token. And finally, the pause key. What the pause key does is if someone has the pause key, they can pause all transactions for a token. Equally, they can freeze all transactions for a token. Custom fees, that's a whole nother thing. Custom fees, they're also very, very powerful, cool features, but we're not going to be covering them in this particular lesson or 6 week. So yeah, we'll get started with building this fungible token. So firstly, we're going to set a token name because we need to set a token name. So you can call this whatever you want. I'm just going to call it circle FT. Then we're going to be setting a token ID, token symbol, sorry. Token ID gets automatically generated and given to us. So we're going to be setting the token symbol, and that will be CSFT. Again, this can be whatever you want. We'll also be setting a treasury account. Now, the treasury account is just going to be the same account as our fee-paying account. So I'm just going to pass it in as that account now. So the treasury account is account ID. Now, for those of you who may not remember, we're essentially pulling this process.m.account ID. We're pulling this account information in a secure way by taking it from this .env file, the environment variables, and this just corresponds to our ID over here. So there, we've set the treasury account. We're also going to set an initial supply. So we'll set the initial supply to be, let's say, 1,000. Now, what this means is that the treasury account will receive 1,000 tokens just by default. Just as soon as the account is as soon as the token create transaction is submitted to the network, then the account ID, which we've set, the treasury account ID, is going to have 1,000 of these tokens inside of its balance, unless we add set decimals. So if, for example, I set the decimals and I say, okay, there can be 2 decimals. Does anyone want to have a guess what the actual initial supply might be if I've said, okay, set decimals 2, set initial supply 1,000? This is a bit of a tricky question. I can understand why I even just look at it like, what do you mean? Hopefully when I explain it afterwards, it'll make more sense. But could anyone have a little guess of what might happen, how many tokens the treasury account will be deposited with if I say set an initial supply of 1,000, set decimals of 2?
$500.
Not 100, but close it. So it will have less. It will have 10. We'll have 10 because when we've specified that it's got 2 decimals, essentially you can't enter a decimal point in as a number in JavaScript. So what this will be reading it as, it's basically going to be saying 10.00. Now, if we wanted to say, okay, I want the treasury account to receive 10.02 tokens, then we'd say 1002, and that would be processed as 10.02. Likewise, if we wanted to do 1142, then that would actually process it as 14.22. So I hope that makes sense. If, for example, we set 3 decimals, then the decimal place would be moved from the 1.42, sorry, from the 14.22 to 1.42, and so on. So yeah, that's basically that's the adjustment you need to make. Similarly, when it comes to sending the amount, if I want to send 10 tokens, I'll actually have to send 1,000 tokens, 2 decimal points. So for the time being, yeah, we'll set it with 2 decimal points. I want it to be deposited with 100. I'm going to add 10,000. Decimal point will be placed over here, 100.00. The token treasury account will receive 100 tokens. Because we're setting an initial supply, we don't necessarily need to set a supply key. However, because I want to demonstrate the mint fungible token function, I will be setting a supply key. So we're going to say set supply key, and that's going to be private key dot public key. Now, this is something which I touched on last lesson. I know a few people here weren't here last lesson. Now, the reason why I can say private key dot public key is because I've actually converted this private key here into a slightly different format. So if I hover over private key, this variable, it tells us that it's of the type private key. However, if I say over here, and this is what we were doing in the first 2 lessons, if I say over here private key is equal to process.m.key, which is just this string, then it says private key is of the type string. Now that means that it doesn't have this public key property. If I try to type in public key, it's popping up because this is like automatically generated, but it's not actually a function. It's not actually a property within this private key variable. So what I need to do, and what you will need to do, is you'll need to wrap this process.m with firstly wrap it with brackets. This is obviously if you haven't done it already. Wrap it with brackets, import the private key class from the Hashgraph SDK. That can just be done by adding a comma and then copy and pasting private key. And we're going to be getting the private key from a string. We're going to be using the private key dot from string method. And what that tells Hedera Hashgraph is it's saying, okay, look, I've got a string, I've got a private key in the form of a string. I want it to be converted into this special Hedera Hashgraph type. And by doing this, we then convert the string into an object or an object of the type private key. And actually, this can even be demonstrated just to show it a bit clearer. If, for example, so I'm going to console.log, I'm going to say console log private key. I'm also going to console log. You guys don't have to do this, by the way. This is just for me to demonstrate the difference. So I'm going to console log the string, and then I'm going to console log the string when it's been converted into this type. String. Now, if I run this code now, code create. As you can see, we've got our string, which is here, and then we've got our private key, which is this new object. So that's basically behind the scenes, Hedera Hashgraph is converting it, and it's one of the properties within this object which allows us to then access the public key, which allows us to set the supply key. Appreciate if that's a bit bit confusing. It's not totally necessary to know, and obviously, yeah, just basically do it, and then we'll be able to get the correct format for the public key over here. Set the supply key. We've set it with the same account ID which we're using for the treasury account, and now we can actually go to submit it on the onto the Hedera Hashgraph network. If we do that, we'll set like a submit variable. We'll say the submit equals await transaction execute, and executing with the client. Again, this execute means that we are paying for the transaction with our client. Our client is just account ID and private. And then we can get the receipt as well. So we can say const receipt equals wait get receipts. So get receipt with the client. And then once we've got the receipt, we console.log the token ID. This is a fungible token. And we're going to say that is the receipt.get token. So yeah, I'll leave this up for a second, just so that if you haven't copied it up, you can do so. But it's very, very similar to our create NFT. So as you can see over here, we've done the same thing. We've got the token create transaction, submitted it to the network, got the receipt, and then we've got the token ID, and we're just printing it with the receipt. Actually, I'm going to add a plus over here, just because it makes it better. So yeah, I'll move on now. Obviously, we need to invoke this function, so we need to create FT. And now when we save it, again, you can make sure that it's saved by pressing Control S. If it's not saved, it'll show this white circle at the top. Press Control S or right click file save, then Control S. And now we can actually run this function by saying node create FT, and hopefully, there we go. Got our token ID, which has been generated and sent to us. We can actually go have a look at on Hashscan, proof that this transaction has been made. And there we go. Fungible token, Circle Students FT, CSFT, got a supply key. It doesn't have an admin key, doesn't have a KYC key, doesn't have any of these stuff. It does have an initial supply, 100.00, 2 decimals. And at the moment, that's what the total supply is as well. Didn't set a max supply, so that's why it says max supply is infinite. Though infinite in programming doesn't actually mean infinite, it means 2 to the power of 64 minus 1, I think. So it's pretty much infinite. This other stuff you don't really have to worry about, but yeah, as you can see, it's been created correctly. Has everybody seen this result be logged out to their console? Module not found. Right, okay. That is probably because over here you've I think that's because you haven't imported something over here. So make sure that this private key save, maybe, but yeah, make sure you save that guy. That might be it. If it's not that, make sure that you've imported all of the relevant classes which we using the private key class, we're using the client class, using the token create class. We don't need to have this token type.
Not yet, check. Still trying.
Still trying. Well, look, what I'll do is I'll just copy and paste this code into the chat. Few things just to make sure that firstly make sure that we're in the correct directory. So for example, at the moment I'm in Hashgraph seminars, and if I press ls, which means list, it tells me what all of the children files are. So as you can see, we've got this. Yeah, we've got all of these files. We've got node modules, basically all of the ones that we could see over here. We need to make sure we're in the correct directory. Make sure that you're in the same directory as your .env file, and make sure that you're requiring .env.config over here. Make sure that's happened. What I'll do is, yeah, so obviously you've got there's the code available in the chat, which you can copy and paste. If that's not working, we can have a little look later on. But I'm going to move on to the next function, which is going to be a send NFT, or actually send FT, I should say. So yeah, let's do that. So we're gonna create a new file. It's going to be a send ft.js. Now again, I'm just gonna copy and paste kind of this first half, and actually, so yeah, got our create ft.js file, and what I'm going to do is I'm just going to copy the first 11 lines, copy and paste them into our send ft.js. That I don't have to rewrite it all. And instead of doing a token create transaction, we're going to need to import the token transfer. No, just the transfer transaction. So that's this is the class which we're going to be using. Again, all of this stuff is configured correctly. So if I then begin creating our function, async function send ft. Just because we didn't do a mint. Well, okay, no, we'll because this create ft, we've got an initial supply. Yeah, we'll do the send ft. So what we're going to be doing is we're going to again create a new transaction, const transaction equals new transfer transaction, and we're going to be adding a token transfer. Add token transfer. Now we can get a little sneak peek of what arguments the add token transfer is expecting, but we can also reference the documentation. Again, I'm going to pull up the documentation. In this, SDKs, transaction, transfer transaction. We can have a look at what it's expecting us to do. So we need to add the token transfer, set the account ID, and set the value. Now, for this token transfer, it's slightly different to an NFT transfer. Again, if I pull up the NFT file, send NFT, as you can see, here we're specifying, so first thing we specify is the token ID, then we specify the serial, then we specify the sending account, and here we specify the receiving account. The only account that needs to sign is the sending account. However, for the send FT, we need to do it in a slightly different way. And I'll show you what that way is. So first of all, we need to get our token ID, and that can be found just from the console. So this is the token ID. That's going to be the first argument. We need to specify what the token ID is. We don't need to specify a serial because for fungible tokens, serials don't exist. All fungible tokens of the same ID are exactly the same. There's no uniqueness. There's no uniqueness between any two of the same fungible. We then need to specify the account. So going to be sending it from the account ID, because this is the treasury account. This is the account which has tokens. And because we're sending an amount, we're going to be sending a negative number. So because it's leaving the account, it counts as negative. Now, to do that, we just need to say, okay, minus, and let's say we want to send 10 tokens. We're going to need to do 10 plus account for the decimal points, send 1,000. Let me just, and we create a 10, okay. So we're going to send 1,000. That is displayed by the minus 1,000. Then we need to add another token transfer, and this is going to be for the account which is receiving it. To add token transfer, it's going to be the same token. Just copy and paste the same token ID. Here we specify which account is going to be receiving it. What I'm going to do is I'm going to head over to my Hashpack wallet, find it on the Google taskbar. And we'll be receiving it with this account here. So again, the receiving account doesn't need to sign the transaction. Only the sending account, where the money's leaving, needs to sign it, and also the person who's paying for the transaction fee. So I've copied that. I'm going to paste it in here. Now, because this account is receiving the token, it's going to be a positive amount, 1,000. When it comes to building transactions, though, you can actually be far more complicated than this. And this is what we'll be covering next week. We'll be covering complex transactions. But just a little little sneak peek. You could, for example, say, okay, I've got another account. Got this other account over here, change wallet account, testnet number 1. Now, if I copy this, I can say, okay, send 50 to one account, and I can add another token transfer. So firstly, I'll say 50 is 500, 5 is 500 because of 2 decimal places. It's going to be this account. It's going to be the same token ID, 500 here. Now, what this will automatically do is it will distribute 500. It will distribute 500 of the 1,000, or 5 of the 10. Distribute 5 of the 10 tokens to this account, and it will distribute the remaining 5 to this account over here. The only thing which needs to be fulfilled is that all of these must add up to 0. So the net out must be equal to the net in, and it will all cancel out to 0. If it doesn't cancel out to 0, and I say, for example, send out 1,001, and there's only being 1,000 received, this will resolve in an error. But like I said, we'll go into that a bit more next week. You can also add, you can continue to add, for example, HBAR transfers, add HBAR transfer, add NFT transfer, and make them really, really quite complex. You can do that basically to whatever extent you like. But like I said, just for the time being, I'm going to be sending 10 tokens, 10.00, just to one account. So all of it's going out of that account. All of it's going in. Minus 1,000 plus 1,000 equals 0. This is all good. This is pretty much all we need to do. We then need to sign it with the account we're sending it from. Now, because we're signing it with the same account, because we're sending it from the same account which we're executing the transaction with, we do not need to add another signature. However, if the account which was signing the transaction and sending it, aka paying for transaction fees, if that account was a different account to the from account token transfer, then need to freeze this transaction by saying freezing with the client, and then we need to add the signature of the sending account. So this will just be the sender. Now, like I said, because our sender 0.4 is the exact, this is the sender, the account ID. Because the sender is the same as the fee payer, don't need to worry about signing it twice. Just need to submit the transaction, const submit equals wait action executing with the client. This so yeah, this execute is signing the transaction. We're signing it ready, so we don't need to do it twice. Then get the receipt. So receipt, wait, receipt with the client as well. Then we can console log the receipt status. And if this shows up as 22, which hopefully it does, means that we have successfully sent the NFT, sent the FT, sent the fungible token, and we'll be able to check it in our Hashgraph wallet. Send FT, function over here, clear the console, type in node send FT. Actually, this will cause an error. Now, can anyone, before I do it and we'll see what the error says, can anyone remember what I briefly mentioned at the beginning and as to why this will cause an error? Right, so I'll execute the function and we'll see what the error comes up as. So as you can see, it's failed. Receipt status error, receipt for the transaction, blah, blah, blah. Obtained error status, token not associated to account. Now, like I said at the very beginning, with Hedera Hashgraph, you need to associate yourself to a token. And by doing that, only then are you able to receive said token. Associate ourselves with a token. We can do this on the Hashpack app. We need to go to the account which I'm trying to send it to. That's not this account. Test 3 0.34813348. Head over to that one there, and we'll add token, associate a token. Just do that by copy and pasting token ID. Enter that. As you can see, it automatically pops up with all of this information because this information is on a distributed ledger. Basically, it's spread out over everyone. So it's got the name Circle Students FT, the symbol CSFT, infinite supply, 100 initial supply. Associate this token, successful. And now when we go over back to the console, same function, and this time it will work. So what I'm going to do actually is I'm just going to press up on the keypad, and what doing that does is it just it takes you up to the previous thing that you've entered on the terminal. If I press up again, keep going back in time. So yeah, we've got node send NFT, send NFT. Hit enter. Status code 2022. So that means it's been successful. Now go over into our Hashpack wallet and have a look, see that it's been received. And if I refresh the page, as you can see, token transfer 10 CSFT has been received. We've also got this new Circle Students FT, of which we have 10. There we go. That's successfully sending and creating and sending a fungible token. Very, very similar to the creation and sending of a non-fungible token. I hope you guys were able to follow. Has anyone got any kind of little issues which perhaps we can iron out now? So please, and if you were able to do it, definitely drop a little thumbs up. Yes, bros. Were you able to do that? Were you able to create the function, create the fungible token first? Nice. Okay. Cool. But yeah, make sure you're obviously using your own token ID. One thing that I could do to make this a bit clearer is I could say const token ID equals this. Nice. Good stuff, Tom. So what I could say is I could say token ID equals that, and then rather than typing it in each time, it look a bit messy, I can just say, okay, this is the token ID. Similarly, with the sender account, I say, okay, cons. It just makes it a bit easier to understand. Every time I type send FT, the last line changes. Aha. Right. Okay. So that's just okay. So Max's question: every time I type send NFT, changes to SVG animated transform. That's the autocorrect being annoying. Yeah, there we go. Look, it's coming up for me as well. What you should, if you press escape, then it goes out and you can do it. But sometimes, bro, it's so annoying when that happens, man. Like you're just typing something. Look, this is a common one. Console.log. This here. Anyway, that's one which happens to me all the time. It just yeah. So if you press escape, that the window should disappear. You should be able to type what you want. Hedera, Oscar, any successes with you two?
I got lost a little while back, but
Fair enough.
I'm gonna watch the recording and hopefully I'll come back around.
Of course, man. If you'd like to, perhaps you can spend a bit of time. Like if you want to, you can share your screen now, and we can have a little look at it together. Because obviously, I know that we did go through this last week, but I was telling you what to do. So this is your first kind of independent time coding. I can create the token, but still having some issues sending it. Okay, so make sure when you send it that your create the token. What could I say? Make sure that your what's the error? What's the error? And yeah, Oscar, let me know if you want to share your screen. We can also have a little look at it together. I'm sure an issue that you've had will be an issue that other people have. I'll stop sharing my screen now.
Sorry, Jake, just on the code there, you've got constant sender account. Should that be receiver account? Because that's receiving the token, yeah?
Yes. Yeah. Well clarified, yeah. You caught me out twice now with my poor. I'm a bit tired and I'm tired at the moment. It should be the receiver account for sure. This is the account which is receiving it, definitely. Shows nothing on the terminal. Right, are you definitely invoking the function over here? That could be the issue if it shows nothing, because for example, if you try to run it, make sure it's saved as well. But if, for example, if I color that off and I say no send FT, it just comes up with nothing. So that might be what it is. Yeah, Oscar Bro, if you want to, I'll stop sharing my screen now. There we go. Yeah. Oscar, if you want to share your screen, then have a little debug of yours. I reckon it'd be nice and easy.
No, I think I'm too far back, to be honest.
Okay. Okay, cool.
I'm gonna have another look at the recording and start again.
Sure. Okay, no worries then, bro. I'll get the recording sent out as soon as possible. Right. So with getting send FT is not defined, that will probably be because you've called it something slightly different up here. So make sure that you're calling the same name. Actually, what you can do is you can highlight it. If you double click it, it will. Oh, unless actually it might be something to do with your file name. Yeah, either this is a different name or saying node send FT when your file name is actually called something slightly different.